You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's podcast, first thing we're going to talk about in the news section, unfortunately, is the crash of the recent 737-500 aircraft out in Indonesia. So we'll talk a little bit about that. In our second segment, we're going to talk about Bombardier. They have a pretty amazing factory where they produce wings, and they're pretty just high-tech in general. Alan's worked there in the past, so we're going to talk about some of their tech as far as their assembly line goes and all that stuff. And in our EVTOL segment today, we're going to talk about EASA merging its general aviation and VTOL certification, Jaunt exploring their fuel system to potentially extend their range, which is something we actually chatted about last week, Archer finding a production partner, and GM, their crack at the EVTOL market and how far it's now lagging behind. So, Alan, let's start with the Boeing 737. So that crash out of Indonesia has gotten a lot of press, obviously, because, terrible accident. But it wasn't in the air very long, and then it seems to have plummeted 10,000 feet in less than a minute. And can you shed some perspective on that? That seems like a really precipitous drop.
Yeah, the aircraft was at about 10,000 feet. It had taken off and headed over the water, and then just seemed to disappear. And there were some reports from some ships nearby that watched the aircraft plummet into the ocean, and then it sounded like that the aircraft was essentially in a full nosedive right into the water, which indicates really one of two things. If the aircraft has something severely wrong with it, then yeah, you can kind of get in those situations, like you stall it and push the nose down and continue to push the nose down, and then obviously you'll crash in that sort of situation. But most aircraft, when they have some power plant problem of some sort, don't go plummeting downward like that. The airplanes can glide, and you would think you would try to set it up to glide, but it just leads you to think that one of two things happen here. Either the pilot/pilots decided that for whatever reason they were disoriented, or they were, and maybe in some cases there's been cases of suicides, that they just pushed the nose down and drove it into the water. The other possibility is you have some control flight surface anomaly where it just drives the nose down and the pilots can't fight it off. As soon as they find the black boxes for that aircraft, they're going to have a pretty good indication in an hour or two, usually, of what the flight parameters were, airspeeds, attitudes. Cockpit voice recorder will tell you a lot. It could have some previous crashes. So there's a lot still to be learned here. But this is not, I think, one of the first things that happened, and everybody held their breath as soon as I saw this news, was, is it a MAX airplane, right? Is it something to do with the MCAS system? Weird things happen. It doesn't sound like it's a Dash 500, right? And it was built back in the 90s. Does that sound right, Dan?
26 years old, that plane. Yeah.
Okay. So it's been around a long time. And I also heard it was a former Continental aircraft. It came from the United States originally, was flew livery here, and then was purchased in Indonesia. So the airplane has a lot of flight history around the United States. Obviously, all the mechanical logs go along with the aircraft. So if there was some sort of weird structural flight control issue with the aircraft, going back to the maintenance logs would tell you a lot about it. So I think we just got to let the investigators take a look at it, do their deep dive, try to find the black box. That's one of the worst parts about crashing into the ocean, is trying to find the black boxes. And black boxes have a little beeper on them that is activated when then there's seawater or water around. And so it'll start making pinging noises and I don't remember how long that lasts, but it helps the crews locate where the aircraft is and try to find the black box, because there's the one piece of information you really need off the airplane is that black box. And then if they can recover,
which they have, they actually have found them. Mm-hmm.
Good. How deep was that aircraft? Did they say how deep the aircraft was underwater? Was it 1,000 feet or 100 feet under the water? Because that'll make a big difference on what the analysis is, if they can pull some of the wreckage up.
Oh, they're only rated to like a certain pressure level, the black box, like water
No. The
resistance?
the black box is fine. It's but the wreckage crew, the ability to remove that from the sea bottom is limited by how deep it is. That's why a lot of aircraft are not recovered, and they have the little submarines go down and look at them. But if they can actually pull some of the aircraft back up, then you have a much better sense of recreating the aircraft before it crashed.
Yeah, I can't find that data from any of the articles I've read, but yeah, oddly enough, a fisherman saw it go into the water, which is crazy. Can you imagine seeing something like that? Man, he said it just hit the water like lightning and just exploded. So
well, having an eyewitness is actually very helpful because you can eliminate a number of things. Was the aircraft on fire? Yes or no? Was the aircraft intact? Like, was it missing a tail or is it missing an engine? Most people have a hard time discerning that kind of stuff. But if it is something they had seen, it is helpful in the accident investigation. Those eyewitnesses, having looked at a lot of accident eyewitness accounts, they will vary a lot. If a large group of people has seen that accident occur, they'll have a lot of varying opinions of what actually happened in front of them. But usually if the aircraft's on fire, they can tell it. If the aircraft is missing an engine is one thing they can usually tell. So it at least put some parameters about what the possibilities of the crash were.
all right, so in our engineering segment today, we're going to talk about Bombardier, and they have a pretty amazing production facility overseas. Alan, you've been there before, right? And you attest to the fact that this place is just a modern marvel, essentially. They create wings, they create lots of different parts, but one of their things is they assemble their wings with a lot of pre-pregnated carbon fiber, and that's just a really complicated process in the way that they're made, right? And obviously everything in the aircraft industry is incredibly precise. But you said their facility here just seems to just take everything to the next level.
Yeah. So Bombardier sold the facility at the end of 2020. I think that transaction finally happened. So Spirit Aerospace now owns the facility, but it's the same group of people. It's the same facility that I participated in 10-ish years ago when we were working on the C Series A220 and on the Learjet 85. The technology, the carbon fiber composite technology in Northern Ireland is amazing. Nothing can really describe the capabilities they had in that facility. So they had built a brand new facility because they're right on the water. So if you ever visit Belfast and go to the now Spirit facility, it is right on the water where the ship docks used to be, where they used to make ships. Like the Titanic was made just down the road from where the wing manufacturing facility is for now Spirit. But they had built a brand new facility, and it's a huge facility. And I had an opportunity to be in there a couple of times where they're manufacturing the C Series A220 wing. And it is amazing. It's like walking inside of a spaceship. There is so much technology and engineering going on in that facility to make these composite wings. And they had developed a means of what they call resin transfer infusion. So they're essentially putting carbon fiber in place that's sort of tacked together. So stringers and spars kind of get all put together, and they're let me describe it this way. So when they're making wing scan, they're basically laying down what is essentially dry fabric and putting in some stringers and things into it, and then injecting epoxy into that mold and then curing it. That leads itself to a lot of efficiencies. So you're not working with necessarily a pre-preg material, which is tacky, and there's exposure issues, how much time it can be out, and how does it all cure up. And they're making fairly thick assemblies. And they were the trick that the RTI process was able to do was really compact all the carbon fiber and get the right amount of resin into it consistently. And that's hard to do on very, very thick composite structures. And the A220 wing is very thick, relatively speaking. So they were able to do things that I had not seen before, and the consistency of it was amazing. The other part about what Belfast technology was at the time, is that they were designing the aircraft under the new lightning and fuel system safety rules, which put a lot of features into the wing to prevent arcing and sparking from either electrical failures or from lightning and other bad situations. But essentially, they had designed the wing to be, it's got to be the safest wing at the time ever developed in terms of its protection against arcing and sparking into the wing. And they did that through a lot of technology advancements. And they advanced materials, they advanced design techniques, they advanced failure analyses, and a whole plethora of different things you wouldn't think would come out of a facility like that. You think like Boeing would do that, or Airbus would have the capability of doing that, but it really just came out of Belfast, and it was amazing to watch. And I was there, I don't know, probably 7, 8, 9, maybe 10 times overall. And every time you go there, you just like, your eyes would open up again, like, wow, there's something else amazing going on in this facility. Because a lot of times when you go visit an aircraft facility, a lot of the things are old. It's just old technology. It's an old facility. It's kind of dirty. It's industrial. It has all those little features like going into an old automotive factory, similar feel. But in Belfast, it wasn't like that at all. This new facility was just completely different and amazing. So I know that there's just keeping track on what they've been doing lately. They're making some other advancements. Queen's University has a site at the Spirit facility on campus, right there, right near the front gate. So they're working with the local university and all kinds of other universities and technology centers around them to improve their products. And I always think their products are amazing. So I just like watching the technology jump out of there because it's such a cool facility and it's full of really, really bright individuals.
So, I mean, how have you seen like production facilities evolve over the years? I mean, obviously they're still continuing to, but I assume they have a really long shelf life, number one. So that probably, I don't know, does that stifle innovation? Does it always take like a brand new physical building to really make big leaps and advances in like production technology?
It does. I do think there is a mental aspect to that. And you can feel it in the way the employees react. When you walk into a facility that's sort of pre-World War II or just post-World War II facility, which is what a lot of aircraft companies still operate in. You can tell it's old, things don't work right, it's dirty and dusty because it's industrial, and it just, that whole general wear and tear happens. And I always feel like there's not going to be a lot of innovation there because everything says to you old, aged, not new, right? Nothing new is being invented here. In fact, in a lot of cases, they're still building the same airplane they were building back in the 1950s or 60s in the same spot. So nothing has changed in 50, 60 years. So you get that feeling, right? And also, I think it just builds upon nothing new is going to be invented here. And when you do build a new facility, even with all the expense of it, right? But I think it just opens up mental doors to people. The sights and the sounds and the smells, everything's fresh. And that, I do think that opens up creativity. I think that's a lot of times out in Silicon Valley, they're all in these new facilities and they're all changing the way what they're seeing. There's more windows, all those different things you don't necessarily see in an industrial environment. You more aggressive, quicker paced technology companies get rid of all that stuff and get away from all that old world kind of an industrial environment, just because I do think it produces more innovation. I think it does.
All right. So in our last segment today, we're going to talk about EVTOLs. And so first on the docket, EASA is sort of refiguring its certification, merging the departments that will handle their fixed wing and their vertical takeoff and landing aircraft, which will also include drones. So, Alan, obviously you speak all the time about certification and just how difficult it is. Does this seem like an obvious move to you? Does this seem to make sense?
Well, there's a lot going on, and I've been reading a really conflicting stories lately about the certification world. So EASA is creating new rules for EVTOLs where the FAA is not. The FAA is saying I have existing rules. And that is a dichotomy that we don't see very often, where the European regulators and the United States regulators are not on the same wavelength here, because you want to have consistency across those certification groups. For example, if I'm making a small Part 23 light aircraft, I want to be able to sell that in the United States and Europe and not have any additional rules. Back eons ago now, Europeans had different rules than the Americans. So you'd certify the airplane in America, then have to go do a bunch of extra stuff to certify it in Europe. And it just led to barriers of entry. That's what it does. It slows down your ability to recover your investment in this product, because even though your marketplace is in the United States and it's a 300 million person marketplace, you still like to pick up Europe because there's a lot of business aircraft activity or small aircraft activity over there. So the EVTOL difference in certification approaches is, I think, really unique. And I have not heard of a merger yet. Usually they try to get everybody together and work out differences. Haven't heard it yet. So if I'm a EVTOL maker in Germany, like Lilium, I am concerned that I'm going to have two separate rules, because Lilium may be successful in Europe, but they really need to get that offered into America also. And having two sets of rules is going to be just added cost with probably not much difference in safety.
Yeah, gotcha. So moving on, Jaunt Air Mobility is considering partnering with Vertigo Aero. And if you don't know about Vertigo, they produce Jet A hybrid electric systems with a 100 kilowatt or 180 kilowatt generator coupled to high efficiency battery packs. So Alan, we talked about this last week, where, you know, the legitimacy of some of these EVTOL companies is going to depend on their range and the battery technology. Can they actually make these flights and, you know, make numerous flights in a day? They can't just fly to Manhattan from Long Island once and then recharge for 6 hours. So Jaunt, which, you know, they have the gyrocopter sort of design, they're not afraid to, it seems like, explore this hybrid electric and battery powered model, which probably makes sense. And at least a certain percentage of the EVTOL market probably needs to do that, right? Because otherwise everyone's going to be maxed out. If everyone only uses battery power, everyone might be maxed out of very short trips. How do you feel about this potential partnership?
I think it's the first of many. And I bet you there's more activity going on that front than we even can imagine right now. The battery technology is going to be limited, and if you are intending to make multiple trips, short trips in a day, then either you're going to be pulling batteries in and out, like the sort of the pipistrel design will allow you to do. You can actually pull it out and plug another series of batteries in, or you're going to have an auxiliary power source to supplement the battery charge system, battery energy storage system that's there. Otherwise, you're going to be sitting on the ground a long time. There's nothing wrong. I think there's some feeling that if it's not 100% plug it in, charge it, fly it, that it doesn't have any value in the marketplace. That's a very invalid approach. I think if you have a design that is much more versatile and it can fly longer ranges and do multiple flights in a day, is much more valuable than an aircraft that can only make 2 flights a day. So I would envision multiple other sorts of technology, like we've seen some hydrogen technology pop up recently. There's going to have to be some play for that. This Jet A systems, there's going to be some play for that, because at the end of the day, where you want to get to is you do want to be able to plug it in quickly, recharge it. That'd be an ideal, but we're just not there yet in terms of battery technology and recharging technology and all the other fronts. We may get there in the next couple of years, but I got to sell airplanes today to keep my airplane company alive. So make the sacrifice, put in the additional power system so you can at least start production and sell an aircraft. I think that's the minimum you got to do right now. So I think we just got to keep listening to see where more of these things are going to happen. And I also kind of wondered with some of the automotive companies coming into play and joining forces with the EVTOL players, if that's part of it, is coming in with essentially the ability to make high efficiency turbine gas burning systems that create electricity, that would also make a lot of sense. So we'll see how it plays out.
So next up here is Archer. So we talked about Archer Aviation briefly on the show in the past. They have a prototype, looks very interesting. And they've partnered with Fiat Chrysler Automobiles, FCA, and they're hoping that FCA can give them some input into cockpit design and a lot of those things that the automaker, has been using in their cars. And of course, Archer's design is potentially going to give them up to 60 miles at a top speed of up to 150 miles per hour. But do you feel like this is my question for you, Alan, do you feel like small companies like this need to partner with these bigger firms, like these automobile companies? Like, does that partnership make sense?
I think at a top level it does. One, there may be some financing going on, so some funding may be coming from Fiat Chrysler that will help propel the aircraft to becoming reality. Great. I think there's also this assumption that the procurement system within a automotive manufacturer is probably pretty robust, and they know how to drive down costs and to purchase things in quantity to drive down that cost while also maintaining quality. And if you're a new aircraft company, you don't have those people on staff. Well, Fiat Chrysler does, and they clearly do. And then the assembly aspects and how to make a factory work, which is sort of the Toyota Joby situation, that if you're going to make as many aircraft as what you're promising to make, and then you need to really set up your factory in a certain way to be efficient, Fiat Chrysler can do that also. I always think when a heavy industrial company comes into an aircraft company, aircraft companies tend to produce things in dozens. We may produce a dozen aircraft a month, something like that. And then you get a company that is making dozens of cars a minute. That they're so different on perspective that all the information you're getting from the automotive company is coming like a fire hose at you. You can't absorb all the things they're talking about that quickly and try to react to it. And the automotive company is going, why can't you aircraft guys figure this stuff out? So they're just living on different planets, and it's going to be very hard for them to even talk the same language about how to do this thing, because the aircraft engineers are all about safety and reliability and all these other things, and Fiat Chrysler, any automotive manufacturer, is about shoving cars out the door consistently, repeatedly. Both of those things can coexist, but there really hasn't been an aircraft company that has done that in a long time. So when you bring in a partner of that size, I think there's a lot of risk for both sides that this whole thing is just never going to work, because you almost need somebody in the middle to negotiate both sides and explain what each side is talking about, because it does feel like that. You feel like this automotive person's talking about putting on wheel lugs, and we're talking about putting on wings. How can they help me? Right?
I mean, I could see, especially from like higher up executives who have, automotive production experience, whereas maybe some of these, like this new company, it doesn't have an aircraft yet, but getting from one aircraft to thousands of aircraft, that requires a lot of scale and production lines and, nimble, like choices of design and also of parts. Elon Musk has talked about this. He's like, we don't want to just design the best new battery. We need to design the battery that can make sense for thousands and thousands and millions of cars. That's so you'd think they could help with that, but I think you're right that in the day-to-day, like gritty of it, it might be hard to marry the two types of engineers and figure out how they're going to work together when their designs are fundamentally very different.
Yeah, I definitely think so. When I came out of college, we used to work for what was General Electric, became Lockheed Martin, and we made spacecraft. So you talk about the lowest production rate of anything in the world, but probably the most complex thing in the world. So we made one or two or three of these spacecraft, and the amount of rigor going into every single one of them was just absolutely off the charts. And moving into the aircraft industry, it's like there was like no controls at all. That's what it appeared like to us. There was like no controls on anything. You couldn't track parts. You don't know where that part necessarily came from at the level of detail. There wasn't sort of the planning and the controls that we had seen in spacecraft. It's just a totally different world. And if you take that down to the next level or over to the next level to automotive, there's going to be even less. So any particular vehicle running down a Detroit manufacturing line is not really an individual like it is in an aircraft. It's just being sort of pushed out down the factory line with, there's a lot of details that go into it, but it's just not the same level of rigor. And until you can become comfortable with that, you always think that it's chaos. And it's not chaos. It's organized chaos, I guess, but there is a method to the madness, and it's just very difficult for an aircraft company, an automotive company to try to join together. I think that has not proved fruitful in the past.
Yeah. Well, and speaking, this is our last topic for today is, General Motors unveiled a Cadillac branded personal drone a number of years ago, and kind of circling back to them, it's, GM was hoping that it would get to speeds of up to 56 miles per hour and be a rooftop to rooftop sort of personal travel device. The design is very bizarre and unlike anything that exists currently, in real aviation. And this article out of EVTOL.com just says, they're very far behind other designs nowadays, with, more and more players coming into the market. Yeah. So I know how you're going to feel about this. So why don't you just come out with it?
Well, I don't understand why they're even trying, honestly. It's not in their level of expertise. It makes no sense. It's not going to drive customers to buy their cars. What technology are they going to possibly develop in an aircraft that they're going to apply to cars, or cars into an aircraft? I just don't see it. And they have no expertise in certifying anything aircraft related, and which they would have to do. So what is the point of this? I don't understand what the point of that is, because I wouldn't buy an aircraft from General Motors. So last time General Motors or Ford or any other Chrysler, any of the other automotive manufacturers in America built aircraft was World War II. And after World War II wrapped up, they immediately got back into the car business. They were not going to make airplanes. And so now that they're sort of tinkering around with it, any automotive company tinkering around with it at that level doesn't make any sense. Honda, years ago, I thought did it the right way, in which they basically created a separate division, and it was a pet project for a while, no doubt about that. But they actually set up a separate division to learn all the stuff they needed to go learn, and then when they had a very productive and useful design, they then decided to build a factory and make it, and that has been productive. But that was like a 20-year development program. Mm-hmm. I don't see GM spending 3 years developing this, because the return on investment in the United States, it was different than Honda was doing at the time over in Japan. GM can't do that, not now. So why toy with it?
Well, and I misspoke. This is a brand new design. This is not a couple years old design. This is a brand new design, but they just appear multiple years behind based on the design they've released. Yeah, sure. And it seems like GM is excited about their battery technology, and they're just trying to find more places to put it. That seems like the whole impetus, which
is that a Tesla move?
They said their battery system is called Ultium, Ultium. Right. I don't know much about it beyond that, but I think they're just trying. It seems like they're just trying to fit more uses to it, which seems misguided.
Well, if you're trying to compete on the marketing side with Tesla, Tesla's not even trying to market. They don't market anything, right? They don't pay a single dollar towards advertising. They haven't. And they're on both ends of the spectrum. They're on the automotive side, which is mass production somewhat, and also on the rocket side, which is very slow production. So they got both ends there, and they have made it a conscientious decision to stay out of the airplane market. So if Tesla's staying out of the aircraft market, that should tell you a lot, because it's a super risky, not that spacecraft aren't, but having the general public flying your product is a very risky investment, and why GM would want to go into a place that Tesla clearly doesn't even make any sense to me.
All right, well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.